Hey, this is Randy Kirk, and I can't believe that twice in 1 week, I'm going to have the best set of doctors in the Tesla world, all assembled in one place. I've got, let's see if I think I have your name at least right now. I have Dr. Scott Walter, and we have Dr. John Gibbs, Dr. Know-It-All, Knows It All, here to follow up on Investor Day. And in case you don't know who I am, I'm Dr. Randy Kirk. I can actually use that, but don't ever call me that. Nobody knows that. Anyway, okay, so the three doctors now will discuss what happened on Investor Day. So I'm going to let Dr. Walton, I'm not going to call you that anymore. Scott, I want you to take the lead because apparently some people think there was some CGI going on.
Right.
Oh my gosh.
Right.
Okay, wait. There was, but not the part that they were talking about. That simulation stuff is beautiful. I mean, that's really nice. That's CGI.
Yes, that was like an absolute another. And there's definitely a lot to unbox there.
No.
And we are just going to maybe talk about a couple because there's so much. And despite the fact that John's a know-it-all, there's a lot there for him to know. And my expertise is like a little bit more robotics, a little bit more manufacturing. So I'll focus on that, and John can then fill in all the other things in there. But the main thing is that it did not occur to John and I at all when we saw the Optimus video that it was CGI. Didn't strike us for a minute that was the case. Yet evidently, I saw one person tweeted me, is it CGI? I'm like, of course it's not. And then some more. And now I'm seeing a lot of people think it's CGI. And I'm just going to hold off for a second here and say, actually, the fact that there's three reasons I say right now why it's a good thing that everyone thinks it's CGI. Okay. But it's not. Okay. Definitely it's not CGI. And if it wasn't real, it might be claymation because sometimes they do look a little bit like that, but it's not claymation. Okay. All right.
So wait.
Yes.
Can I just insert this?
Yes.
Okay.
Yes.
I'm staking my professional reputation here. I have been learning and teaching and working professionally in the 3D animation realm since 1996. So we're approaching 30 years in this.
Yeah,
I've seen it all. I can taught it all.
I was there at the early days of computer graphics at Cornell, and a lot of grad students I worked with were working on the ray traces and stuff like that. So I got a little bit of an eye on whether it's going to be real or not. Yeah. Okay.
But anyway, I will stake my reputation that this is actually, Scott, you're right. I mean, stop motion would be far more likely than CGI.
Yes,
I mean, I don't know why or how they could do that, but they could have the little.
I mean, it's all but I mean, the first reason why is that it's good is that we've all learned to be skeptical about everything we see nowadays because all the deep fakes. So I think that's very positive that at first everyone's impression is, wait a minute, is that really real? I should be skeptical. And I'm glad they're doing that. So that's really good. The other thing is the reason why everyone is going to, it must be CGI, because what they're seeing, they really think is unbelievable. And that's good because we've seen in science fiction, robots do some amazing things. Yet we know that's fake. And we have an idea already, these expectations of what we know a robot can and cannot do. And I'm actually happy about that people don't think robots can already do what we're seeing in there. Right. So that's the second thing that's pretty good. And now the third reason, and this is why one of the people that contacted me, why they thought it was CGI, and that is it looked so much like the CGI at AI Day. So remember AI Day, you had the human being, or you had the robot that was walking that looked like the evolution of the walking gait. And they're going through. And I pointed out yesterday in a video with John that there are basically three types of CGI in the way I view it. Okay. First, there's artistic CGI, where you put together something through CGI that artistically looks very good and is lots of fun, but there's absolutely no reality behind it, that the motions and everything you're doing is just because your eye tells you that's what it should be. Then there's animated CGI, which is coming from like a data set of some sort, where you've got real world data and you're using that to drive the motion you're going. It could be like the motion capture doing it a human being or something else. And then there's simulated CGI, where you actually are taking, you're creating the data set. So the difference is that, like, if we take an example of like a crash test, So, two cars get into an accident or something like that, and you have this black box and it records all this data, and we can get the data and we can compile it into a table, accelerations and velocities and turn rates and all this other stuff. And that's our data set. We say, oh, here it is. And anyone that looks at it will say, I can't interpret that. I have no idea what that is. So the next step is you can take that information and we can just make we can chart it. We can make some plots out of it. Now, engineers might be able to interpret it, but the average person is like, I have no idea what this means. So the next step is you take that data and you actually now animate it and you show the motion the car is going through and we can all understand it. So that's animated CGI, that you're taking that data set and making it very easy for you to see. The simulated one is where you now create that data set through like computational fluid dynamics or FEM or kinematic or something like that, which is what Tesla has been doing. They have a very good physics model that's able to sort of predict what something is going to look like. And then they take those numbers and in order to visualize them, because charts and graphs don't cut it, they actually make it move. And of course, that was then used as a feedback loop for the neural network to teach it to walk. So the fact that these real robots look so good to their physics makes people suspicious. And what that tells me is their physics engine is really, really good. And now think about it for a second. We've all seen the Tesla crash test where they show the real one and they show the simulation and they overlay them, and they are so good. I mean, the crumple zones, everything is doing exactly the same thing. And that's because they're very good at being able to understand how things work. So those are my three reasons on why it's not a bad thing that people were so suspicious that it's CGI. Now, why is it not CGI? Part of it, John, you can go in the technical, but one of them comes right down to a very simple thing. Why would Tesla even think of doing that?
That's exactly.
Trevor Milton learned the hard way about doing something like that. Those are not trucks rolling downhill, okay? There's something else. And no one else in Tesla would have allowed that to happen. There would have been a hue and a cry from everyone saying, no way we're going to make a CGI and not let everyone know. The whole idea is we're trying to show people where they are. But I could not see any artifacts or anything in there that would tell me there's things wrong. If anything, it shows me that it was real because there were a lot of edits that you could see. You could see that they shot a lot. Now, it doesn't mean the whole thing, the continuity. We can argue whether that wasn't one shot, that was multiple shots.
Yeah, definitely.
Believe me, John and I learned the hard way yesterday how hard it is to get one good take. Because
you want to try it again.
This morning's video was the best take. Oh yeah, that one. So you've got that going on, and that there was, you could see that when they did the edits, they got a few things wrong here and there because they had different camera angles, but they had a professional come in there and so it was not scripted, it was staged the way a director would. So a director is deciding the lighting, the camera angles, and he's telling the actors, all right, let's do it. Do it again, But it's up to the actors to actually improvise and do everything. So that's the one thing. And then we can get into actually what's going on in Optimus and mechanical and stuff like that once we get the CGI. But okay, like we said, we talked about earlier that we actually have someone who is like a trained attorney over here. We figured that out, that we were being cross-examined last week. We've come in for a deposition today. And like my attorney would be over the side pulling like, shut up, you're talking too much, So here we go.
So John, do you have anything to add to that? Is there any more from your technical expertise that would?
Yeah. Okay. So again, I completely agree with Scott that I clearly during AI Day identified the simulation that showed it getting better at walking as a simulation. That was clearly, and also it was obviously a simulation to my eye. So
everyone would see that.
Yeah. So here we have Tesla not putting up front that this was a simulation would almost constitute fraud-ish. Trevor Milton is going to jail over this stuff, or is in jail. I can't remember if he's there yet. Yeah. But anyway, so number one, bad idea. Number two, I, with my own eyes at AI Day, watched the prototype Optimus walk around, and it wasn't that much more complicated than what we saw there, right? I mean, obviously huge advances, but I'm saying nothing physics breaking. And why don't people think that the Boston Dynamics Atlas robot, I mean, it does backflips and stuff. That's way more, that's crazy. You know, if you're going to say something CGI, that should be it. But then when it comes down to details, any individual picture, like if you took a still frame, you might be able to fool me into whether it's CGI or real. But the second that thing's animated, I can always tell. And the only way around that would have been to motion capture a human being doing it and put them in that, and then incredibly effective. You know, when they show their simulation software, it's so, and maybe a lot of people are like fooled by it, but it is so obviously a simulation to me. I'm like, whoa, okay. You know, it's like, that's not real. So I'm just telling you, I have almost 30 years of experience, you know, training to look at this stuff. And I would hazard a guess, let's take any other animation professional out there. I mean, if you're working at Industrial Light and Magic or EA or Steam or where Ubisoft, whatever, come on the show if you want to and debate me about this, because I have a feeling that anybody who's in this industry and spends their time looking at this stuff is going to go, yeah, that's real.
Right. And you've had the guys that were CGI experts and they tried to do the moon landing and they said, it's real.
It's real. Yeah.
It's absolutely real. Yeah.
The problem with CGI is the same thing. It's weirdly enough, like if you try to like make an image in DALL-E 2 or Stable Diffusion, it's too perfect, too smooth. There's lots of, I mean, if you just look at us, we got all sorts of little imperfections all over, you know, and the way that we move is weird. And the way that Optimus was moving was weird. There was these, Scott, I think you know the technical name, but I call it overcompensation oscillations, where it's doing kind of a Newtonian.
Oh, you mean the Gibbs phenomenon?
Yeah, the Gibbs, yeah, it's going like,
he can never remember that
all the time. It was like vibrating.
You'd think Gibbs would be something he could come up with. Yeah.
Exactly. I know. Sorry. I always forget that. Maybe it's because I just don't want to call it, like, it's not me, obviously. It's somebody way smarter in my family tree. But anyway, but you know, all of those details, individual frames, the details in those frames, and then especially the motion. Like I'll just tell you, when I go watch movies, as soon as I see a CGI stuntman, it throws me out of the movie every time. I'm always like, and it's because of the movement. You can always tell because it doesn't move right, or I can always tell at least. So I'm just telling you, 27 years of doing this business, that's real.
Yes.
And also Tesla would get in huge trouble if it wasn't real.
And then the other question becomes, why bother?
Yeah. Yes. There's no upside.
More work to
There's
make
nothing but downside. There's nothing but downside. Yeah.
Right. There was and also, just one other thing to put in here. That was an afterthought. You could see the flow of the entire presentation, and they're like, oh, we got it done like 2 hours ahead of time. The guy sends in the cut, and Elon was just standing there going like, oh yeah, that's Optimus. And they had no idea he had probably never seen that.
Yeah.
So it wasn't a buildup. It wasn't the big reveal.
Right.
Like if you think about it in the grand scheme of things, it was just awkwardly wedged into this thing. So again, why would you go through a massive amount of effort to defraud the public? Yeah. To putting something that nobody would have missed if it wasn't there.
Right.
So, and as far as everyone's case, you know, they don't factor in Optimus at all.
No.
Yeah. Just like they don't calculate, but so why throw that in there? I mean, even if it's there, no one is going to put it into their models. No. Wall Street definitely won't. They don't care. It's like, no. So
it's crazy. It's crazy.
Absolutely no upside.
If it was a standalone company,
and
they were showing what they've shown with Optimus, it would be worth 50 billion, 100 billion at least. But since it's part of a conglomerate,
and it's not going to move. It's not going to move the price. Yeah. I mean, it's going to make people like us way more bullish. And you know, we're just like, we're diamond hands for sure now.
And let's not forget that Elon Musk said greater than 1-to-1. Yeah, Optimus. So we're talking 8 billion of these things.
Well, that's an insanity. Well, the population is going down, so by the time they get there, maybe, I don't know.
Fine, 7 billion. Let's call it 7 billion of these things. But still, that's a lot of Optimi. Yeah, which I think has to be the plural of Optimus. I don't know.
even if he just gets the numbers up to the same as cars, and it's 20 million in 2030, that would be a massive business. That's depending on whether he leases them or rents, whatever.
Yeah.
all that kind of stuff. So,
Yes.
okay. So guys, now talk to me. I watched your video the other day, but talk to me just a little bit more about what we did see. To me, it appeared that we saw, and this is Randy now, because I have this theory. Again, I want to repeat it to my fans. My theory is this year, they're already building some Optimus, and that was just proven.
But there's four at least. We know there's four.
There's at least four.
Four.
And I believe that Elon said, and there's a few of these around here.
Yes,
Something like
as
that.
far as arms and legs and everything else. So
But maybe he was talking
starting to
about
crank
more
them up.
Optimus. So I'm not exactly
right.
There was a wink and a nod as to how
Yes.
many there might be out there. So part of my theory is that they're making as many as they can right now, as many as makes sense. 3D printing them, making some of them out of machine tooling, whatever, but that they're making a bunch.
Yes.
Okay.
Yes.
So we know for sure, and so cleverly, that they had these two robots building the other robot. I thought that was just hilarious.
Yes.
Like the crowd that was there somehow was so numb by that time that they should have been laughing their heads off at that particular part of it, because it was such a, and then to take the veil off of the picture and show the family. I mean, this was good work. Anyway.
Oh yeah. Yes. I absolutely agree. And the first thing is hats off to you, because now what it's done is that I don't think John and I were not skeptical that there wouldn't be 1,000 by the end of the year, but we just thought, well, it's a bit optimistic, and we weren't quite ready to go out. I'm much closer to your side now, because I'm seeing they have made a lot more progress. You did say something about they would use it on the assembly line. I felt, yeah, they will. I'm just not sure how soon. And it's not like the idea of robots building robots. It's been around in science fiction for a long time. And even Fennec has been doing it since the 80s. And of course, what they've been doing is it's more of a showcase that they have in Japan to show it doing it. And it's not doing everything. There's still a lot of manual assembly. But you get the impression like, oh, look at the robots are kind of putting them together. And then some other rooms, like actually people are putting together. So it wasn't necessarily, let's say, good CapEx, expenditure on that, but maybe good R&D to look into it. And the same thing with Optimus is that there will probably be a lot of things that Optimus still won't be able to do in it, but more and more that they will. And the one thing that stuck out to me is that they keep on talking about, design for manufacturer. And that, now they're shifting, because the mistake was, when they did the Model 3, they were designing it for the manufacturer manually. And then they shifted to full automation. They go, wow, when you do that, your design is compromised, it's not the wrong design. So now they want to go to full automation, but that full automation is including Optimus in the equations, because Tom Zhu made that very clear when he talked about how many Optima you would need for a gigafactory. And he didn't say that flippantly. I mean, he said it in the sense that we are designing around it. And of course, Optimus itself is designed not just to be manufactured, autonomously, but by Optimus itself.
Right.
And, so it's not just that a human can go in there, but they really want to make sure they can do it. And the other things, in many ways, when they start designing things to be done by Optimus, it'll probably be even easier for the human operator. Because there are going to be things that are going to be a bit of a challenge for Optimus at first that the human will be able to do. But the idea is that they're swappable.
Right.
It's not like an industrial robot where you can't do it. So that's kind of one of the big observations. And then we can get down into the technical, but I'll let someone else, talk for a second.
So were there surprises in what the capabilities were? We saw using, for me, the number one surprise was the dexterity, but it was the dexterity of using the trigger on the drill motor. That's hard for me. Because I don't use it every day. I use it once a year or something.
Right.
But be able to push or pull that motor in the right amount to put a screw in a wall, as opposed to tighten a lug nut. Being able to use that amount of dexterity, that impressed the heck out of me. What do you think, John?
The thing that impressed me the most was the flexible object. So it unplugged a hose, which is admittedly easier to hose up, a cable run. Anyway,
Connector,
electrical cable run, not a hose to be specific. But anyway, it did just unplug it, not plug it in, but it did that. And then it was able to grab that piece of cloth that was over the picture, which was awkwardly placed because the picture was always there in the background without the cloth over it. So little continuity issue, but anyway, but it grabbed the cloth and was able to pull it off. That's hard. I mean, doing things with rigid bodies, like the original one from AI Day where it picked up that big kind of I-beam looking thing and moved it. It's like, that's level 1. Right. Then we're talking about tool manipulation, level 2. Then it picked up a bolt, level 3. Now we didn't see it put the bolt into the socket wrench, so maybe didn't get there. But I feel like soft body manipulation is sort of level 4. It's like there's a major level of achievements for Optimus. So, not CGI, not doing backflips like Boston Dynamics, but damn, those are really impressive.
Yeah, it's there. Let's say that there's no surprises on what it did. What I'm surprised is that some of the things they've already done, they've been able to get to there. So it's sort of the speed of things that are happening that impressed me a lot. There's still a lot more fine tuning and refinement, but they are definitely getting better. And it looks like they've made a couple of good decisions, especially when I look at the wrist, because if you remember, I famously sort of said they would only have 2 axes on the wrist. So that you would be missing this kind of movement in the wrist, because it said it was only going to be a 6-axis arm. And you could look at the actuators that you had 3 of them up here, 1 at the elbow, there's only 2 left for down here. So that was very clear. And then when you saw the wrist come out at the shareholder meeting, it was very clear that they had the movement for the full thing. So it's like, well, I was really wrong. And then we saw the video of Bumble B and C. In the original version, they only had 1. They learned from it. And it was a poor design because the actuator was down here. So it really was a design asking to be changed. And when they changed it and moved something up here, they realized, hey, if we do this, we can also get it to do this almost for free. So they had to add an extra actuator to it, but they got it. And if you look at what's going on with the drill, they are really using that a lot more than I expected them. Right. So that it's a little bit almost superhuman. And the thing is like, David Price will know about this, the pitcher for the Red Sox who played too much Fortnite, so he got carpal tunnel. Optimus doesn't have to worry about carpal tunnel. So he's able to do some of these things that may give him a bit more accessibility. And it had to be a bit careful because the other thing that was interesting was the decision-making process that it went through when it went to pick up the arm. Yeah. And then it suddenly decided that one hand, it was going to rotate around and grab from underneath. And a lot of times you do that kind of movement. And for you and I, if we are doing something completely palms up, we're feeling it in our forearm. It's a little bit uncomfortable. It's saying, is that really the way that you want to do it? Are you going to be comfortable doing that? Maybe you want to come around like this. It'll feel a little bit better. So ergonomically, it may not necessarily be the best thing, but you could see his hands out there. Yeah, no problem. I got this. Right. And because there's one thing I think I'm going to see that they're going to do with Optimus at some point, and they're going to use it also for ergonomics if they have to have a manual kind of station that you would go through and kind of look at that stuff. And then you have to be careful. Oh yeah, Optimus had no problem doing it. And then you put a human in there and he was like, oh man, that's a stretch. Yeah, so they may have to be careful. They may have to scale back it a little bit to make sure it actually matches human motion a bit more. But that's very good. Yeah. Can
I jump in about the wrist thing? Because the wrist, I can't repeat the movement because we don't have this kind of flexibility in our arms, but it was able to turn its wrist 180 degrees with the arm still straight, right?
Yeah,
like upside down, like this, roll axis. Yes. But it's a small thing, but the fact that the cable runs are flexible enough and this thing is robust enough that it can turn its wrist 180 degrees and all of the mechanics in the fingers still function to the point where it looked like it was playing a violin. I mean, it was like every single finger. That's beautiful, right? Yeah. That's not something
that's why all the servos, right? Yeah. That's why they're all actually in the hand. So there's nothing that's, because otherwise, you do that and things get kind of complicated. And again, they won't be able to do like plus or minus 3/6. I mean, they could, but we do that. You do have to worry about your cable starting to wrap up. So
but that's what I was saying. It's that the fact that you don't have the actual actuator cables running through the wrist that would bind if you flipped it upside down. So it's really,
right. It's very and definitely it looked like it was playing a Stradivarius or something there, the way it was holding it.
So what is the do you think is the next step if that's
right? That's it right there.
Oh,
the next step is improving the walking.
improving the walking. Okay.
Yes.
And then with regard to the walking, so that it's more fluid, so that it's faster.
Both. And the thing is, when it becomes more fluid, it will become faster.
Right.
I see.
So all they don't have to worry about making it faster, just worry about making it more fluid. I think the one problem is going to be they're going to be thinking about the foot right now, because remember I talked about they wanted to put 3 axes in the wrist. Right now we only have 2 axes in the ankle. And because you kind of don't need it, because except unless you want to go pigeon, it's hard to do. If you want to go pigeon-toed or duck foot or something like that, you can do that. But most people don't. When you walk, you're in a certain way, and you don't really care about this and that motion. The only time you care about this and that motion, kind of, is when you're trying to turn a corner. And you notice when it was trying to turn around, it was like really awkward, and its knees were bending in and everything else. It's because when that foot was planted there, they're not getting anything there. And in one of the videos, there was a close-up shot, and I've been looking really, really closely to figure out what's going on. They don't quite have an actuator joint in there, but I think they might have a compliant joint. And there was like a wire going in there, and I'm like, okay, is that wire because they're actuating something, or is it just because they have like an encoder in there, they're trying to measure where that is, or a force plate or something like that? But to me, I think rather than putting an actuator down there, they're going to probably have some sort of compliance to allow you to make that so you don't get an ACL tear or whatever, with the ankle, and that will allow them to do it, because that term is awkward.
We'll have to have a robot sports injury clinic.
Yeah. So it'll go, it'll probably be able to walk straight, okay, but then suddenly you need to change direction, and it's like, the Titanic here, or just barely, okay, now we can kind of go straight. So there's a few things they need to move.
What about
and that also tells me why it's not CGI. If it was CGI, I'd make the walking
also
awesome.
Let's go back to the CGI thing. A human being, if you had put a person in a motion capture suit, capture that data and put it on the robot to make it look real. Okay, so you got the actor that's doing weird movements and stuff. No human being is going to do that bizarre pigeon toe thing, and also no human being can flip their wrist over like that.
Right.
These are just impossible movements for people.
Yeah.
So what about the visual coordination? I thought that was the other thing that was really surprising. That it wasn't just that it could do the operation, but that it was coordinating the visual aspect.
Yes, right. And visually, possibly too. I don't know how the collaboration was done or cooperation between the 2 Optimi, because one of them had to bring the arm up to be held in order to be bolted in. And so was that kind of a visual confirmation? Is there some sort of communication, some Bluetooth going on between them, telepathy going on? So there was like a little bit of coordination to make sure you're going there. So that it's not like you weren't expecting that. I just wasn't expecting that too soon. For me, a lot of it comes down to proprioception that they have and what the hand is doing. Because if you look at the hand design is adequate. But we've seen better ones. I mean, we've seen the open AI one where it's doing the Rubik's Cube and stuff like that. And they have a lot more control in those fingers. And there's a lot of others out there that you'll see on the internet, these wonderful hands. And why haven't they taken those designs? Because if you look at the hand has almost nothing. There's no encoders in the links here. Absolutely none. They're relying just on the tendons and what's on there. And then they've got to be relying a little bit on what's going on with their fingers. Now, proprioception is very complex. You and I have a pretty good idea.
Define proprioception.
Okay, basically, it's our sense of the
pick things up,
let's say the topology or configuration of our bodies without actually looking at it. So I know where my arm is right now without seeing it, because I can sense where my arm is just. And if you want to think about it from the standpoint of a robot has a joint and it has the motors. And it has encoders at the joints. And the encoders at the joints tell it that, your wrist is down at 45 degrees. It just tells that. And the same thing with your elbow. We don't have that, but we do have proprioception, which tells us that kind of indirectly through the tension in our skin, in our muscles, and the tendons. There's all these things. For a robot, it's very easy. It's very linear. And anyone can hack into the signal coming from that arm and probably reverse engineer what it is. However, even with my eyes closed, I can tell you that this right now is 180 degrees. This is 90 degrees. This is like about 135, plus or minus 5 degrees. I'm not that accurate, but I have a pretty good idea of where it is. It's so good, I can close my eyes and I can take this finger and touch my nose without looking. And I can touch my earlobe, and I can turn my head and touch my lip, and I'm not even seeing because I have such a good sense. And then I can change fingers very easily. And it's so good, I can grab this and in my mind's eye, with my eyes closed, still be able to do something like touch my nose. That's a remarkable sense that we have, and also that the robots can do. Now, it gets even better when we have the feedback loop of our eyes that we're going on there. And now where I'm going with it is that we could, if we were able to hack into the, whatever the data is coming from a robot stream, we could eventually figure out, oh, I bet that's this encoder here, stuff like that, and say that's telling us it's 45 degrees or 90 degrees. With the human, we are getting noise. And that's what Neuralink is doing. Neuralink is plugged in, and they are getting this totally noisy signal. And you look at that and say, there is no signal there. It's just pure noise. Yet somewhere along the way, they were able to figure out from all that noise what that pig was doing when it was walking, and know so well that they could send that noisy signal back and get it to also twitch and do everything else. So what's going on with the hand, with a complete lack of any sensors and the very little data, like just back EMF when they know they want to close, and then suddenly, wait a minute, something feels a little bit funny here. They get a sense of what's going on with their hand. They have gone through and done so much of that stuff, and with the neural networks, they have a pretty good idea of what the finger is doing. And then you tie it in with the eyes, and you've got that feedback loop. Wow. So to me, it's the two that's going on there. And also, I'm wondering if there's some people from Neuralink, that are kind of going over and giving, or some ideas, because somehow they took those noisy signals at Neuralink and turned them into a model of what's going on. And this is a lot easier for Optimus, trust me, because there's not that much data. It's just crazy values that you now have to say turns into a configuration of a finger. And then the feedback from Optimus again and again, it's learning and learning what those things are. And we do that every day. We know exactly what it has to feel like for our arms to be. And then there's the expectation that when you pick a bottle, you kind of know what the feel was going to be. And before you even grab it, you already know what it feels like in your head, right? You're already simulating that in your head. Optimus is doing the same thing. And it's going over there. And if it doesn't quite match, then it says, oh, okay, what's going on? It's like, I was expecting a glass bottle, but this is plastic. It feels a little bit funny. I was expecting an empty bottle. This is full. It will be able to tell that really quickly, and then maybe confirm it by looking at what's in there. And so it'll build up that and build up and build up. And it's all about S-curves.
So again, sorry, go ahead.
John, John.
Just to throw in the unplugging of the conduit that it does right at the beginning when it pulls the conduit out, that's a case of proprioception. It's able, because just take a giant clamp and it goes crunch and it just destroys, it just crushes it, right? That's not what you want to do. You want to delicately grab it and pull it with just the right amount of torque on your fingers to not crush the conduit, but give it enough friction that you can pull it out and disconnect it. So, that's why I'm so impressed with that. The second thing is that the one thing that they still haven't shown us after AI Day 2 and after this presentation is what's going on in the head. And it's so frustrating. It's like everything else, they're like, here's what's happening, but they won't show us this stuff. And I really want to pop the top off.
And that's where I get impressed, because I've been known for my snark and everything else. And I was the first one to say when everyone was going, oh, but Atlas can do backflips. And it's like, when was the last time that backflips was part of the job description? Right. Even a gymnastics coach doesn't have to do backflips. He just has to show how you do it. And there are different use cases. If you're going to have a firefighting robot, I want it to be Atlas. Okay. I do want one that's doing parkour. But if I get someone working in the job site, I do not want Atlas doing backflips after he's handed me something on the top of a scaffolding like that. I want it to be Optimus, okay? OSHA will come in there and shut you down in no time. So in the factory, you don't want parkour. You don't want any of that stuff going on. So you want to be careful on that. And the other thing is everyone was talking about, the hand and stuff like that, and it's going to be able to grab an egg. And again, it was like, when's the last time you saw eggs on the shop floor in a car factory? I'm just not aware of that.
I however, would say that
coming
after
on over and picking that up, and I'm
Yeah.
going, I bet they can pick up an egg now.
I was going to say, after watching that demo, I think it could pick up an egg without breaking it.
It can pick up an egg.
Yeah.
All right.
Yes.
So now we come down to usability, and again, this is, we're coming back to Randy Kirk's theory. So as we saw it right there, I saw it using a drill motor to do a task. So if the task on the line in the factory right now was merely to take a drill motor up and place it properly and pull the trigger back the appropriate amount so that it would then put the whatever it was, the lug nut or the screw or whatever it was, into the appropriate place and then pull back and wait for the next one. Yes, that could be done by an existing robotic arm, right? Right, Scott? But
yes,
would it would look to me like Optimus now could do that task?
It could do a lot more. So again, kind of one of my early replies when we were looking at the shop floor and what was out there, and everyone likes talking about the low-hanging fruit metaphor, and I was like, you go to the shop floor and not only is the fruit hanging low, but a lot of it is already on the floor rotting, just waiting to get picked up. So there's many of those like that. But then after I saw that thing, I was like, screw the low-hanging fruit. Optimus is picking the fruit from the treetops, So he's doing a lot there, absolutely a lot. So it's progressed pretty quickly and will be useful very quickly. And I'm sure it's already being put into service in some places to get the data, because right now, my thesis is aligning more with yours with the numbers, because we always talk about the strength of FSD is the fleet. And you can only do so much with simulation. You got to get out there and you got to find out that, floors are not as flat as you think. They're not as solid as you think. They're more slippery than you think. You got these different surfaces. You can only get so far with the walking. You need to get more and more and more of that. And so they're going to start collecting more and more real world data. And the only way to do it is you've got to start getting a much bigger fleet and a greater variety of tasks and everything else. And they're going to accelerate. And if you kind of draw a line of where Optimus has sort of been, where we've seen it, you're going to be one of those things where if you want, you can draw the line to be a linear line and look at it and say, it's not going to be useful till 2025, 2026. Or if you're Tony Seba, and let me remind you, Tony Seba spells his last name with an S. It's an S. It's the start of an S curve. And what we're seeing is that we're kind of on this S curve right now. And let's see where we are in April and May.
Yeah.
And we're going to see it is not a straight line anymore. They are starting to get a lot of that data. They're confident enough in the mechanical design to go with what they have. And then they will go with, a version 2.0 when they learn enough, because that's the other thing is when cars do the road test, you have them in threes. You've got to have them in threes, because when they go out there and something fails, they want to know, is it something, and they run the same test. I mean, the drivers, you've got them, you're following a lead car the whole time. You're always in the same lane. You always make the same turns. You always go the same speed. You always pull over at the same place. You always get gas of the same. Everything about those is the same. And if two things happen to fail at the same time, we've got a problem, because there's something common. If not, maybe it's just a runoff. The other's a one-off. Something about that. So they want more and more test data of doing a lot of these same kind of operations to see, did we design the joints right? Are they wearing out? What's going on? Have we, the motors, did they overspec the motors or underspec them? Because if you look at the hips, it's like, man, talk about, gluteus maximus there. Woo! It's like, those are some big motors that they've got there for walking. And I wonder if they oversize them and if they're going to learn after a while whether they need to change that for balance reasons and everything else. So there is a lot going on and the bigger the fleet, the better.
John, I want to be sensitive to your time. I know that you have a hard break in 15 minutes, but a soft break right now. So,
I'll stick around. This is a really fun conversation. My wife is trying to get a hold of me right now, but I'm like, put her off.
Put it on mute. Put it on mute.
So John, what else did you see in that in the video and or the implications of the video?
Well, again, and I just thought of this. This is another counter argument against the CGI thing. But one of the things that impressed me a lot was the fact that at least one of the robots was walking around untethered. Now, one was sitting on a table. The other one apparently was hanging in the background, and the other one never moved. It just kind of stood there, I think. But at least one of them was moving around untethered. And the confidence to be able to like allow this thing to walk around, we don't know, it is possible that they pre-scripted a lot of this stuff. We don't know the details. So they may have been like, go here, move 15 degrees. I doubt that that's exactly what they did, but they could have been that. I mean, that's what Boston Dynamics does, right? I saw a whole video about how just doing the backflip, they had thousands of simulations and it repeated it exactly the way that they had, so you can do that. I don't think that's what Tesla's doing, but they might have done that. But yes. Elon Musk, while he was watching the video, I remember this now. He said, "Oh, that couldn't walk during AI Day," like pointing at the specific.
Right. Yeah, exactly.
And that doesn't sound like CGI to me. That's
that's right. Right.
Remember one that couldn't walk. Yeah.
Yes. So, yes. Now, there was one other reply to one of these tweet threads out there that someone just said, "Look, as far as a hand, it's like, oh, when are they going to teach you to give the middle finger to Wall Street?" And if you remember when they did like the photo, you had like this thing with a hand. Ask an Italian what that means, So I think there was a subtle dig in there.
There is a difference in Hawaii, though.
Yes, that's true.
So John, was it you or was it you guys together, or did I see it somewhere else, making the suggestion that the new cell method of assembling the car, the new third generation car, this way of pulling it together from all directions, was basically going to be that Optimus might have even, how would you call it, caused them to think that way, that getting all the robots close in, etc. Help me with that, John.
I'll start first, but Scott knows better than me. By the way, just a little breaking news thing. Joe Tegmeyer was very kind. Our video today, we said we don't know how they're fitting the side panels onto the other part without spot welding. And he provided close-up pictures from someone who was at AI Day or Investor Day, and apparently may have been violating their NDA. I don't know. But where he got the pictures, I don't know. But they're close-ups, and they clearly show that the panels and the middle part are put together. There is, and there's just a nut and bolt, that just a bunch of fasteners.
I know some parts are put together like with the castings in the underbody. They have that. I'm just wondering about the side panels, and you have
this was the side panels.
But you would have to have a lot. I mean, some of them would be there for really good structural integrity. But the other thing you have to be concerned about is noise, vibration, and harshness.
Right.
And how many bolts, and that's why you have a lot of spot welds. Because you want to keep it rigid. You want to get rid of, the rattly nature of it.
Yes.
You do a little bit with sealant, but that's why the higher end cars like, Lexus and Mercedes, they don't spot weld. They're doing a linear weld there to get a long one to get rid of that. So,
yes,
but then if it's a cheap vehicle, who cares? If it sounds like a Fiat, maybe it's
no. But that I was just watching Connecting the Dots did a video today, and he was talking noise NVM.
Yeah,
noise
NVH,
vibration,
NVH, yeah.
Yeah, NVH, sorry. He was saying that is, and for me, it's the number one thing. If I get in a car and it starts squeaking, I'm like, where the hell is that?
Yep.
And if those fasteners aren't working right and they get loose over time and they start doing this, that's going to be.
I mean, that's a whole thing. You got to make sure that you've got really good Loctite on there to make sure they don't come loose. And the other thing is you are going to have to put some sort of sealant in there.
Yeah.
And the thing about sealant is everyone hates sealant. And sealant is liquid, and we would like it to be a dry factory. So unless they're going to some sort of gaskets or something else that would be able to kind of put that pushback to pick it up, I don't know.
There's going
to be some mystery.
They have, I think it was with the battery, the structural battery pack, and the way that it's fitted to the bottom. It was actually a soft gasket that was pressed into place.
Yeah.
They might do something along the lines of that, but even that, that's messy because it's loose, it's wiggly. You have to get it in the right spot. Not conducive for robots.
I mean, it's not as bad as the paint shop doing the sealant. It's still something there. It's a small footprint. There's not all sorts of these environmental issues and all. There's going to be a little bit of volatile, so you're going to have to make sure there's a little bit of airflow. but it wouldn't be that big a deal. And they're doing it everywhere. And when you put the windshield on, you've got to put sealed on it. So it's pretty hard to get rid of all that. But I already told you my thesis is to get rid of the paint shop, and they're all roads are pointing in that direction. That
I just want to say that I did a video in July of 2020.
Yeah.
July of 2020. So we're talking almost 3 years ago, where I said they're going to get rid of the paint shop for the next generation vehicle.
Yeah.
And I did the design. So you can go back and look. It's on YouTube.
Right.
It came out,
all right.
I think it was July 11th.
July,
something like
it's
that.
all there, and it's becoming more and more clear.
Right.
And
This was just obvious. It's like, if you're going to make a cheap car, one of the most expensive, complicated things to do in the assembly process is paint the stupid thing.
Yes.
And you know, stainless steel has problems with corrosion, but Tesla has a patent now pending that's published where they talk about anti-corrosive stainless steel that won't pit, won't have problems with salt water. You know, all of it's like all roads are leading to them, not
to that. Yes. And it doesn't mean they will only be one color. Either through a tempering process, they might be able to get a natural different color for them.
Right.
Or why not industrialize the wraps and put them into the factories?
Yeah.
You know, I'm pretty sure there would be a process for that. It shouldn't have to be aftermarket.
Yeah.
And Tom Zhu definitely let it out today, or I guess through someone else, a tweet that claims that he said, you know, paint is expensive.
Right.
Just flat out, paint is expensive, and it's like he wouldn't confirm whether the next car is going to be stainless steel or not.
Right.
But we know it's not going to have paint, and there are alternatives to stainless that could be done. And if you don't believe me, just ask anyone who drove a Saturn in the 1990s.
Right. Which is the other possibility. But if you do stainless, you know, if you think about it, like, let's say you do want a red Cybertruck or something, it's like, okay, that's $3,000, and the $3,000 is basically taking the whatever those wraps are. What are those? Ceramic wrap. What, you know? But taking one of those and just wrapping it around the vehicle in the factory.
Yes, but it could maybe it can be done actually when the side panels are made.
Right.
You know, so it won't be the meticulous thing that you've got someone out there that's doing this, but there may be a more industrial scale process that you know, you just.
But that's what I mean is that,
saran wrap over and.
Right. There's the cyber, because remember, we've also got the multi-cell feeding system. So what you do is you just, like, somebody ordered a red one, and you just feed in the red parts. So, you know, and you don't get the color matching problem, because these wraps, the color, because it's sort of baked into this whatever material, plasticky stuff, it's going to be pretty consistent across the rolls. So, you know, you don't have to, one of the big problems with paint shops is you have to paint, like Scott and I were talking about, you have to paint the whole car at once and then take it back apart, or else the paint doesn't match.
Yes. Even though you're ordering red, it's never the same red. The color match is very difficult.
Yeah.
So I'm sometimes I'm fast and sometimes I'm slow, and in this case I might be slow, and I think maybe the public might be slow. I think what you guys have been saying from the beginning of this video until now, that maybe the public gets and maybe they don't, is that the factory in Mexico will be designed around Optimus having tons of function.
It could. Definitely, it's designed to not have a paint shop for two reasons. One, the paint shop is expensive, and second, that's the biggest consumer of water in the factory.
Right.
And it's environmentally, it's nasty. I mean, if you explain to people the worst part of the production process is probably going to be the paint shop. There's all sorts of volatiles there. There's all sorts of treatment you have to do.
So again, but I think it doesn't have to be designed for Optimus from day one, because it sounds like they want to get this thing done in 12 months.
9 months. 9 months.
9 months.
I think producing cars in 12 months. That's what I mean. It's not done, but like cars rolling out. But the idea will be that whatever humans are doing there, Optimus can step in. So it won't be any crazy contortion like up underneath the thing,
It's designed for Optimus, for sure. It's 100% designed for Optimus. Absolutely.
That's really so interesting. I mean, because you think about, the original Dreadnought idea, that just turn out the lights and turn on the factory.
Yeah. And the other thing is, it was also confirmed that the Berlin paint shop is not coming to Texas or Fremont.
Oh, wow.
Interesting. Wow.
Yeah.
So I guess that super cool red color is only Berlin.
I'm convinced it's not because they're getting rid of necessarily paint and color. They're starting to learn that there are other ways to apply colors to cars that does not involve paint in this process. And that paint shop is really, really advanced over in Berlin. But what you're seeing is the last throes of a dying technology. Wow. It's the Kodak Advantix moment.
So, right? Okay, so let's go to Wright's law for a second.
Yeah.
You know, Wright's law is the idea that every time you double production of something, so we could consider painting a car to be production of an object. Every time you double it, you have a certain percentage of savings, but that means that you follow an exponential curve, and eventually it flattens. And we've been painting cars since the Model T and before, so that's a lot of doubling. So we're at the flat part.
But
so if they can do something new, if they can do something new, they get all those doublings and they get to reduce the price very rapidly.
And painting is really, really hard. People do not understand what it's like. And that, first of all, I mean, from the standpoint of having the robots do it, you see the robots are moving around. Creating that program is very simple. We've done that for a lot of customers and everything else. And believe it or not, the number of points involved are not that much. They're really not that picky about having a dense concentration of the robots to move. So it's very easy to take the CAD data, to figure out how to slice it up, and you get the moves that's going on. And you bring it out there and you'll do the paint, and the paint job will look horrible. Now, when we do offline programming for spot welding or arc welding, we can download and it will work the first time, good quality and everything else. Painting is very difficult, even when you try to simulate it, because no one can really simulate it, because what it's doing, it's a turbulent environment and there's so many variables and everything else that's going on. So at that point, all they want is a robot that's doing reasonable motion, where you're normal to the surface, you're a certain distance apart, and that every pass after it is a certain distance over. Now you think, oh, so they're going to go in there and going to tweak the points. No, they're not tweaking the point locations at all. Now they have to go and tweak the process parameters. And the process parameters are all these things that have to do of the paint flow that's going through there, of air pressure they have that can actually sort of change the shape of the cone. You've got downdrafts you have to worry about in the paint booth, and all these environmental regulations, because you cannot just vent that out into the atmosphere, especially if you're close to Munich, like BMW was. And, I think over 25, 30 years ago, they had to completely redo their paint shops to get all those volatiles out. So where do they go? In the downdraft, into the water down below. And now you're going to treat that water and get rid of it. So you get that nasty thing. But the main thing is you want to come up with a quality paint job. So you go over and you do it. And you've got to remember the flow that's coming out is a Gaussian distribution. So you've got more paint in the middle than the outside. Now they try to do all these things with electrostatics and everything to try to make it as linear as possible. But the fact is you have kind of a curve. And when you go over the first pass, you're going to have high and low spots. So now the second pass you come over, and where those low spots are, you want the other low point to come over to fill them up and hopefully keep it even. But if you look at it underneath, if you measure the distance, you're going to see peaks and valleys and peaks and valleys. It's never flat, no matter how hard you try. So you get the guys that are out there and they are tweaking these parameters, and they're doing it for the longest time. And the customer will give them a body to paint. And they go out, they paint the whole thing. They do all these different processes to, try to look at what it is. And there's all kinds of things that are wrong, and they got to touch it up. And now they have to paint the next body. But they don't have, they might have just a couple of bodies. That body, they go out, they got to strip the paint off and bring it back in and try again. And trial and error and trial and error and trial and error. And they get it. And finally, they get it perfect for that color. It's like, all right, we've got black. Now let's get white. Now let's get red. So it just goes on and on and on. And
so the bottom line is that if we can be in stainless steel, phenomenal.
Yes.
But the wrap is the way to go.
Or plastic. I mean,
despite the
plastic.
Or plastic. Yes. Now
so on a wrap, how long do wraps last?
Depending upon who you get it from, I think they can last pretty long now. So if you're willing to get like a ceramic wrap from 3M, I think that lasts forever. You get some of these cheaper wraps, that might be a couple of years. And then they ruin your paint job, because when you finally have to take it off, it takes the paint with it. But then the whole thing is like, why'd you have a paint job in the first place? Just put it over the bare metal. So,
all right. So, but if you had a lifelong wrap, that you could put on a car, Yeah, why would you ever
Yeah.
paint again?
Now, I don't know how scientific this is, because I put a couple tweets out here today about pretty much the end of the paint job, saying that, the best paint job is no paint job.
Great job.
And everything else. And I was expecting there would be a lot of people coming back to kind of that. And it's some of the most likes I've ever had for like one of my own standalone tweets, not trying to clout chase on anyone else. Like, there were a lot, and there was no negative comments, and a few people kind of agreed. It's like, yeah, there are going to be people who want their car painted, and there's going to be that luxury market. There always is. But the majority of people don't care. And they're always upset how their paint gets scratched and have to maintain it. And if people are so much into their paint jobs, why are so many cars just white and gray? It's because people don't want to spend money, and they just want a car that won't rust out for them. So I was expecting there'd be a lot more, and there was like way more agreement than I thought. It's like, yep, the total addressable market for cars that have to be painted is much smaller than you think.
Yeah, but also let us keep in mind that explicitly the Mexico factory is for other areas, developing nations, South America. You're looking at people where money is absolutely, no blame to them. It's key to me too. But spending $25,000 even on a car is a huge investment. So a person like that is like, if this thing lasts forever, I could care less what this looks like. It's this, or it's a crappy old, 3-year-old RAV4 or something.
Any color but rust.
Yeah, any color but rust. Exactly.
That's all I want. Any color but rust.
All right. So now on this other issue, then we started on it a minute ago, John, the way that the cars come, you were talking about how the car will come together in this new factory. The way they showed it, it was beautiful. The simulation was really, really cool. I guess it's not a simulation, whatever you call that thing. My non-pro.
That was CGI, by the way.
That was CGI.
They call it kind of an animation. Yep. It was an animation. Yep.
An animation. So the animation, they showed it coming together from all different directions in one cell. And is that the specific place where you or others might have been talking about the Optimus will be more, what makes it more useful in that environment? What did he call it? The space-time efficiency or space-time density.
Right. Yeah,
so instead of manufacturing a whole car that's big, several meters long, and you can only fit a couple of people around it, and they have to move around a lot. If you manufacture individual parts, you could put 4 Optimi or people in that station. And if it's on a high level thing, it drops down, you do your stuff, all 4 of them, 4 robots don't even have to walk, which is why I don't think they're worrying about the walking so much right now. It's like, don't fall over. That's all we care. But it's like, it comes down, they go, blah, 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 they do their thing. It goes up, it moves. The next one comes in. You got 4 of these suckers that are just constantly doing stuff. They never have to take a step in that case. I
think the analogy is like too many cooks in the kitchen. Yeah. There's so many things that have to be done to that car body. We talked about it being like the keel of a ship. And the thing is, you can only do certain operations at one time because everyone else is in everyone else's way. And so what they're doing is like, just imagine that you have, the tray, and you've got all the plates on the tray. Okay. And now the tray comes to you, and now you get the guy who is doing the entree. He's assembling it right there. Then it goes over and the next guy that's going to be assembling the salad and the dessert. It's like, wait a minute, you know what the smart thing is to do? Is if they're all off somewhere else, creating the dessert and the entree and the salad, and then we just put them on the tray afterwards and go, and we're done. So that's the whole idea, is that you can now work more in parallel rather than serial. So it's all happening at the same time. And all those areas are going to be much easier for Optimus to work on, especially the side panel. So the side panel that's going in there is going to be more than a piece of metal. There's probably going to be some stuff in there. There might be cabling and other things, connectors that are in there that are going around. It's going to be very easy for Optimus to go in and put them in, get the connectors, whatever, and then they come in and they get snapped in. And my feeling is there's not going to be very much snapping. There's going to be things that just plug in. There's no need. Why are we having these gangly cables that someone's going to go and do that? If you line everything up, why not just have a socket interface where something plugs in? We do it with our computers all the time with their docking stations. Right. You just drop it down and it's in. So why not do that with a dashboard assembly and all these others? So you'll see less and less wires and just more sockets of things that will be going. It
requires the whole point of this thing, though, is that you have to have known stable interfaces between each of the modules that has to have incredibly tight tolerances.
Yep.
But given that, given that you can do that, and Tesla obviously thinks they can, at that point, things like having just the plugs that are built into those modules, and when you put them together, they plug in.
They just plug in.
That's a no-brainer because the tolerances already have to be so tight. I mean, the whole reason why you have all these gangly cables is because people are literally, taking 2x4s and wedging things into place on the assembly line to make it work because they don't quite line up right. That's why you have to have a lot of slop in there.
So I know that we could, the three of us could go on for another hour if we chose to. There's so much to talk about. But given the subject matter at hand, which is primarily Optimus and how Optimus has matured in just a very, very short time, let me go around. Last thoughts. Last thought, John?
Oh, ask Scott first.
Man, I was hoping you were going to say, I didn't get to go first here.
See, I just
believe me, we're speechless. Oh wow.
So my last thought was that I think we didn't really touch on enough in terms of the visual, and as you pointed out, this perception of where everything is in space. Is that is the beauty of a humanoid robot as compared to an in-place robot arm, is that if you've got a bolt that's coming along the production line, and that bolt is always supposed to be in the same place, or it always is exactly the same place, well, a robot arm can handle that.
Pure proprioception, that's all.
Right, but if it's off a little bit, if there's a reason why it might not always be in the same place, then that's where the robot can say, oh, it's off a little and just move slightly.
Exactly. Because most industrial robots do not have a built-in camera system.
Right.
That's an add-on.
Right.
So this has always been, to me, from day one, as a manufacturer, I know I'm in rarefied air here with regard to the technology of manufacturing, because after all, I'm just a doggone law student, But I owned a manufacturing plant for 29 years. And as a manufacturer, an in-place robot of any kind, or a automation of any kind, when it's in place, I mean, everything else has to be exact and perfect. But day one, I'm like, no, I would buy Optimus the way he was, the way I saw him the very first time, and put him in my plant right now.
So I'll go ahead and throw in my final thoughts. I'll just go back to what I said before. The thing that I really, really want to know is the brains. I really wish that we could pop the top off of the thing and look at how the cameras are working. But more importantly, I would love, and I think it's just mostly FSD beta, more or less, but I really would like to dig into that. And I hope that sometime within the next 8 or 9 months, they'll do another AI day, and they'll really let us, even if they don't let us take cameras along, if they're like, this is what's going on inside, I'll be like, oh yes. So that would make me happy.
They did kind of promise us an ongoing, a little, tutorials or whatever you want to call them. And so we've had 2 now, just little ones, short ones, one that was done as just a video, and then one on Wednesday. So it's not quite one a month, but maybe we'll have another one in another month or so.
Yeah. And I'll finish with this kind of anecdote, because you kind of reminded me of something that you're just like the small manufacturer and you're ready to take it right now. Well, there's a story, and this is, before it was called ABB, it was called ASEA Robotics. I think it's like 1972. And ASEA had come up with the world's first all-electric robots. There are other robots out there, but this is the first one where everything was all electric. It was the IRB6, and they were kind of showing it off. And they weren't quite sure what it would be good for. And there were a lot of people that came and looked at it. And all the big wigs and stuff like that, we could do that. And there was some farmer who looked at it and said, I'll take one. And everyone was like, what? What's he planning on doing? And they brought it into a shed. And he had this application where he was just doing grinding. He was just taking these parts and grinding them. And he saw this would be the perfect application for it. Went in, because the thing is, farmers, between the morning and the evening, when they have all this other stuff, they don't have a whole lot to do during that time. And they have to find other hobbies. So some of them become like carpenters and woodworkers and stuff like that, and just do all the other things. So this guy's hobby was grinding stuff and stuff like that and selling it to make some extra money. And he put the robot to work. And the robot worked and worked. This is the first one, the very first one, serial number 1. It worked and worked so long that when ABB wanted to put it in the museum, they had to buy it off of him and give him a new robot. So he actually, it cost them more to get the robot work. And you can see it in the ABB Museum in Vestros. So, and I point that out because the thing is, all the people you think should see it have scotoma, and they don't see what's the obvious.
Yep.
And it's the normal person. It's the guy with the horse sense, the common sense, that sees immediately, you know, he doesn't have to go to Excel and do an ROI calculation. It's like, I got it. I'll take one. How much?
Right.
Yeah, that works.
Yeah. Exactly.
In some ways, it's a simpler calculation at that point. It's like, you know, you've always said with the people putting the tops on the bottles, it's like, can it do that? Yes. Oh, cool.
Send me
You know,
one.
it's not a complicated calculation. It's like,
Yes. Yeah,
oh, excellent.
yeah.
That works.
So that's what's going to happen is there's going to be all these people that they see the use case and they'll do it. And everyone else, oh, should we go that way? Should we go that way? Should we go that way? And they're thinking about it and do our ROI calculations. And by the time that's done, this guy's already made profit.
Right, exactly. All right, guys. Well, great. That was a lot of fun. And John, you know, we'll let you get off to your vacation. Good for you. I guess it's Easter break.
Spring break, but yeah, it's spring break. So I'm going to the mountains to go skiing. So, you know, I'm going to the winter. I'm going to winter.
All right. And Scott, great to have you back again. And
Same here, Randy. Yep.
Thank you so much. And listen, you all, if this is good, you know what to do. But mostly on my channel, you know what I want is the comments. Yes, I want you to like it. I want you to subscribe. I want you to join my Patreon. I want you to do all those kind of things. But mostly, I love the comments. And then while you're at it, get up here and get Scott needs some Twitter followers. I mean, I'm sure John does too, and I do too. But Scott's kind of the new guy on the Twitter, and so he needs some followers.
It's slowly going up. I don't know if I'm in that S curve phase right now because it was very, 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 very slow.
And I'm sure John wouldn't mind if you followed him and gotten his Patreon either. So I'll try to remember to put all that information below so that
thank you very much, Randy.
Everybody gets that as well. All right, guys, and thank you all. And by the way, it's been great talking to you.
You too. Thank you.
It's been a blast.
Click the link below to get your paperback, Kindle, or audiobook now.